Hello and welcome to Morehouse's Math Menagerie, where outliers are always welcome. Today, we're going to be talking about significance tests for one proportion. After once again losing a football game to the arch rival, a college's alumni association conducted a survey to see if alumni were in favor of firing the coach. An SRS of 100 alumni from the population of all living alumni was taken, and 64 of the alumni in the sample were in favor of firing the coach. Suppose you wish to see if a majority of all living alumni are in favor of firing the coach. What are the null and alternative hypotheses for a significance test for P equals the proportion of alumni who are in favor of firing the coach? Well, here we're looking for a proportion, and we're told that we're seeing if a majority of the alumni are in favor of firing the coach. So a majority be more than 50%. So our null hypothesis is going to be that nothing's going on. So it's the idea that the true proportion is equal to 50% or 0.5. The alternative hypothesis here would be that a majority or more than 50% are in favor of firing the coach. So it would look like this. Now, to look at the null hypothesis, I know that it seems that we should have that P is less than or equal to 0.5, since we're saying that it's not a majority, but the null hypothesis for AP stats is always an equals to. So we say it's equal to the boundary, and then the alternative is that it's greater than the boundary of 0.5. Now, given the same scenario, we're now asked to draw the sampling distribution and label the sample proportion. Well, we have hopefully a normal distribution if we check the large counts condition. And we're claiming here, since we're using the null hypothesis as the assumed truth, that the mean is going to be 0.5, since in the null hypothesis we believe that the population proportion was 0.5. The standard deviation here of the sampling distribution of our p hats would be equal to the square root of 0.5 times 0.5, or 1 minus 0.5, divided by the sample size of 100. And that's what the sampling distribution would look like. Now, we got a sample proportion of 64 divided by 100, or 0.64. That is over here somewhere, and I'll label that here in blue, just at an arbitrary location. We know that it's more than 0.5, but we're not sure where in here that is. And when we run a hypothesis test, we're looking for the probability of getting our sample's results or something more extreme. More extreme would be away from the mean. So we're looking for this area here. Please note here that this is a one-tailed test because the majority is just a greater than 0.5, not a different than 0.5. So this blue area here would represent our P value, or the probability of getting our sample's results or something more extreme, given that the null hypothesis is true. Thank you for joining us. I'll leave you with this quote by Bruce Lee. Have a great day.